Hi there, and welcome to this Rawkode byte. In this episode, I'm going to take a look at the traceroute command and try to help you understand what is actually happening at the packet and networking level to make that traceroute work. So let's take a quick look at this small diagram I put together. When we make a request to google.com from our machine, it's not a straight line to google.com. There's other networking devices, typically routers and switches, in between, which have to forward on our request until we get where we need to be. So it's not uncommon for something to leave your machine at some sort of local router before eventually getting to some exchange, before eventually getting to some other router, before finally getting to the website or IP address that you've requested. Each time we hit a new device, we call this a hop. Now, our machines, our operating systems, don't want to send packets and wait an infinite amount of time for a response. So they apply something called a TTL, a time to live on every packet that leaves the machine. Let's assume that the TTL on a packet that we are about to hypothetically send is 2. We send it from our machine, it gets to the yellow router. The yellow router will decrement the TTL from 2 to 1 and forward the packet to the next machine. Once that packet gets to the pinky red router, it's going to decrement the TTL. It's going to go from 1 to 0. When that device sees the TTL as 0, it knows that we're giving up. We're not going to forward it on to any more machines. So it will actually respond to my machine to say, hey, this expired. A traceroute takes advantage of this mechanism of the TTL. And when you run a traceroute, instead of applying the default TTL from your operating system, which is typically a value of anywhere from 64 to 255, then it sets the TTL to 1. What that means is our machine will speak to the yellow router will decrement the TTL from 1 to 0, and the yellow router will respond. Now our machine knows a little bit about that hop. It will then increment the TTL to 2. This time we reach the pinky red router, and we get a little bit of information about that. Our machine will continually increment that TTL until it hits our target machine, and we get back a normal response. So what does that look like when we run the traceroute command? Well, I have performed a traceroute to google.com. We can see the first hop is my local router, and it's pretty fast, and we get information back because that router responds to the ICMP ping. There's another networking device after my router which did not respond, and that's why we get ****. It's important to note that that isn't a problem. It just means the device didn't really want to answer the request. However, if we go on with another TTL slightly larger, we hit this next device, we get another device that doesn't respond, and then we get a few more on and on and on. We can see that it takes 9 hops before we reach google.com. And we can see the round trip time in milliseconds for each of these connections, giving us an idea of where problems are when we make a request for a certain website. We can narrow it down based on the information we get back from the hops. And that's how traceroute works. I hope you found that useful. There'll be more episodes soon. Have a great day.